Hello viewers, in today's session we are going to discuss another important application of beta and gamma functions, right? And in this session we are going to evaluate this important integral with the help of the concept of beta and gamma functions. So here we have to evaluate this integral from minus 2 to 5, and here we have x plus 2 raised to 4 and x minus 5 raised to 3 dx, right? So what we will do, we'll first make use of the method of substitution, and we'll try to convert this integral to the form beta function, which is given by the beta integral beta m comma n is given by the integral 0 to 1, and we have t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So this integral is known as the beta function, and we'll convert this integral to this form using the method of substitution. So let us start. So let us first take t is equal to x plus 2, right? And we are making this substitution. We'll replace x plus 2 by t. So dt over dx is given by 1 plus 0. Differentiating t with respect to x, the derivative of x is 1, 2 is a constant, derivative is 0, so this is 1. So we have dt is equal to dx, right? Okay, now we'll change the limits accordingly. So here x varies from minus 2 to 5. So when x is minus 2, the value of t can be obtained by taking x is equal to minus 2 in this relation. So we have minus 2 plus 2, that is 0, and then we have the upper limit as x is equal to 5. So t is equal to 5 plus 2, that is 7. So when x varies from minus 2 to 5, t varies from 0 to 7. So let us now write this integral in terms of t. So we have the limits from 0 to 7. Here we have 0, here we have 7. For x plus 2 we have t. So we have t raised to 4, x minus 5. So from this relation we can write x is equal to t minus 2. So we have t minus 2 minus 5 raised to 3, and for dx we can now write dt. So this integral now takes the form t raised to 4, and we have t minus 7 raised to 3 dt, right? Okay, now let us again make use of the method of substitution. So now let us substitute t is equal to 7 times z, where z is some other variable, and here z can be written as t divided by 7. So differentiating t with respect to z, dt over dz is equal to the derivative of 7z, and the derivative of z is 1, so we have 7. So dt is equal to 7 times dz, right? Okay, now let us change the limits accordingly. So here t varies from 0 to 7. So when t is 0, then the value of z is given by 0 over 7, that is 0. And when t is 7, z is given by 7 over 7, that is equal to 1, right? So now writing this integral in terms of z, we can now write 0 to 1. For t we can write 7z, and here we have 4. and for t we can write 7z minus 7 raised to 3, and for dt we can write 7 times dz. So now let us do some simplification here. We have 0 to 1. Here we can write 7 raised to 4, z raised to 4. And here we can take 7 common we have, or we can take minus 7 common from 7z minus 7. So we have here minus z plus 1, and here we have the power 3, and here we have 7 dz. So we are taking minus 7 common from 7z minus 7, so that we can take up, or we can get the term 1 minus t. That is, here the variable is z, so we can have 1 minus z. So now this can be written as 0 to 1, 7 raised to 4, z raised to 4, and here we have minus 7 raised to 3. So distributing this power over minus 7 and minus z plus 1. So minus z plus 1 can be written as 1 minus z. And here we have 3, here we have 7, and this is dz. Now we have 7 raised to 4. Here we have minus 1 raised to 3 times 7 raised to 3, and here we have 7 raised to 1. So here we can add these powers. So we have 4 plus 3 plus 1, and minus 1 raised to 3 is minus 1. So here we have minus 1. So this is 7 raised to 8, and this is multiplied with minus 1. So here we have minus 7 raised to 8. Right. So now this integral can be written as 0 to 1, and here we can write minus 7 raised to 8, and this is z raised to 4, and 1 minus z raised to 3, and this is dz. So now I can be written as minus 7 raised to 8, and here we have 0 to 1, and here we have z raised to 4. So z raised to 4 can be written as z raised to 5 minus 1. So we can write 4 as a difference of 5 and 1, and here we have 1 minus z, and here we have 3. 3 can be written as 4 minus 1, and here we have dz. Right. So now we can see that this integral is of this form, except the variable. So here the variable is z, here the variable is t, and in definite integrals the variable doesn't matter. So here if we compare this integral with this one, then the value of m is going to be 5, and the value of n is 4, and m and n are greater than 0. So I can be written as minus 7 raised to 8, and this integral is the beta function, that is beta of m comma n, that is beta 5 comma 4. So now to get the value of beta of 5 comma 4, we can use another important result which connects the beta function with gamma function. So we have gamma of m, gamma of n divided by gamma of m plus n. So we have minus 7 raised to 8, gamma of 5, gamma of n, and gamma of 5 plus 4. Here we have 4, right? So this is minus 7 raised to 8. Now we can see another result, that is gamma of n plus 1 is given by n factorial, right? So here we have gamma of 5. So gamma of 5 can be written as gamma of 4 plus 1, that is 4 factorial. Gamma of 4 is gamma of 3 plus 1, that is 3 factorial. And here we have gamma of 9. Gamma of 5 plus 4 is gamma of 9. that is gamma 8 plus 1. So this is 8 factorial. So now here we have 4 factorial multiplied with 3 factorial divided by 8 factorial. So now let us simplify this expression. We have minus 7 raised to 8, and 4 factorial can be written as such, and 3 factorial is 3 times 2 times 1, and here 8 factorial can be written as 8 multiplied by 7, then we have 6, then we have 5, then we have here 4 factorial. So 4 factorial get cancelled. Here 3 times 2 6, 6 get cancelled, and here we have 7. So here 1 power get cancelled, so we are left with 7 only, and here we have 8 times 5 40. So this is minus 7 raised to 7 divided by 8 times 5, that is minus 7 raised to 7 divided by 40, right? So the value of this integral can be taken as minus 7 raised to 7 divided by 4040. Now if we calculate this number 7 raised to 7, you can easily get 8 to 3, and we have 543 divided by 40. So the value of this integral may also be taken as this number. So viewers, this is how by making use of the concept of beta function and all these important relations, we can easily evaluate these type of integrals.